Hello everyone and welcome to the lecture on Amazon DynamoDB. So this lecture will contain all these topics. What is Amazon DynamoDB? Why DynamoDB? Core components, tables, items, attributes, primary key, secondary indexes, DynamoDB streams, consistency model, table classes, Amazon DynamoDB read and write capacity modes, on-demand mode, provision mode, DynamoDB API overview, global tables, and DynamoDB DAX. So what is Amazon DynamoDB? DynamoDB delivers rapid and consistent performance, ensuring efficient data access and retrieval. With DynamoDB, you can easily scale your database tables up or down without experiencing downtime or performance issues. As a fully managed service, DynamoDB eliminates the need for tasks such as hardware provisioning, setup, configuration, replication, software patching, and cluster scaling. DynamoDB provides built-in encryption at rest, simplifying the process of securing sensitive data and reducing the complexity of data protection. You can adjust your table's throughput capacity as needed, accommodating varying levels of request traffic without compromising performance. DynamoDB allows you to create full backups of your tables for long-term retention and regulatory compliance. Point-in-time recovery enables you to restore tables to any point within the last 35 days, protecting against accidental write or delete operations. With DynamoDB time to live (TTL) feature, you can set expiration timestamps on items, which allows the service to automatically delete them when they are no longer relevant, saving storage space and reducing cost. So let's see why DynamoDB, why we should use this particular service. So DynamoDB is a serverless, fully managed NoSQL database service as I talked about, which automatically scales to handle any level of application traffic, making this ideal for modern, high-performance applications. With DynamoDB serverless architecture, you only pay for the resources you consume without the need to provision or manage infrastructure. It can even scale down to zero when not in use, which can further minimize the cost. DynamoDB eliminates the need for version upgrades, maintenance windows, patching, and downtime, ensuring your application remains available and responsive at all times. DynamoDB offers a wide range of security controls and compliance certifications, helping you protect your data and meet regulatory requirements. For globally distributed applications, DynamoDB Global Tables provide a multi-region, multi-active database solution with 99.999% availability SLA and increased resilience. DynamoDB's reliability is further enhanced by managed backups and point-in-time recovery features, ensuring your data is protected and recoverable. With DynamoDB streams, you can build serverless, event-driven applications that react to changes in your database in real time, enabling powerful and efficient application architectures. So the core components of Amazon DynamoDB. In DynamoDB, tables, items, and attributes are the core components that you work with. A table is a collection of items, and each item is a collection of attributes. DynamoDB uses primary keys to uniquely identify each item in a table and secondary indexes to provide more querying flexibility. You can use DynamoDB streams to capture data modification events in DynamoDB tables. So I talked about secondary index, so DynamoDB streams to capture data modification events in DynamoDB tables. Okay, now I will talk about tables. So a table is similar to other database systems, and DynamoDB stores data in tables. A table is a collection of data. For example, I will show the example table called people that you can use to store personal contact information about friends, family, or anyone else of interest. And similarly, you can have, depending on the entity, you can have, like, let's say, a cars table to store information about vehicles that people drive. So it's the whole concept of tables is like a schema-less, and basically you store information about people, addresses, whatever. So it's So as and wish, so whenever you wish, you can add additional attributes with data. And cars can have cars information, vehicle information. So basically table is the main entity in DynamoDB. So now next is items. So each table contains 0 or more items. An item is a group of attributes that is uniquely identifiable among all of the other items. So in a people table, each item represents a person. So if there is something called as cars table, each item will represent one vehicle. So cars table will have, each item will have like a record, you can say, or a row. And items in DynamoDB are similar in many ways to rows, records, or tuples in other database systems. In DynamoDB, there is no limit to the number of items you can store in a table. So there is absolutely zero limit. So it can go to billions or trillions of items also. Next is attributes. Each item is composed of one or more attributes. An attribute is a fundamental data element, something that does not need to be broken down any further. So for example, an item in a people table contains attributes called person ID, for example, last name, first name, and so on. And let's say if we have a department table, an item might have attributes such as department ID, name, manager, and so on. Attributes in DynamoDB are similar in many ways to fields or columns in other database systems. So this is an example table. So this is a people table. So here the primary key is person ID, and then you have last name, first name, phone number, and you have another record, person ID, and this one has additional information like address, but you will notice there is no phone. And same way you have a third person with its own address, and even you can see address does not match. So this have additional field, does not have any additional field called zip code, and this is postal code, and there is no state here. And one more thing, in third record you will see something called as favorite color, so you can add attributes as you wish. So next is primary key. So when you create a table, in addition to the table name, you must specify the primary key of the table. The primary key uniquely identifies each item in the table so that no two items can have the same key. So primary key is similar to any other table which we have seen in SQL or relational database. So basically to identify a item and so that there is no duplication. So DynamoDB supports two different types of primary keys. First one is a partition key, which is a simple primary key. So we call it partition key in DynamoDB, which is a simple primary key which is composed of one attribute known as the partition key. And DynamoDB uses the partition key value as the input to an internal hash function. The output from the hash function determines the partition, which is the physical storage internal to DynamoDB, in which the item will be stored. So this is something to remember. The reason why we call it partition is because it's very similar to the terminology being used for like physical storage location, which DynamoDB internally manages. So in a table that has only a partition key, no two items can have the same partition key value. And then we have partition key and sort key. So this is referred to as a composite primary key. So if you have a partition key and a sort key, so this is sort key is optional, and this then we call it a composite primary key. And this type of key is composed of two attributes. The first attribute is the partition key, and the second attribute is the sort key. So sort, basically sort as like how you sequence or order the second attribute. So based on that it will be sorted. And DynamoDB uses the partition key value as input to an internal hash function. The output from the hash function determines the partition, which I talked about, physical storage internal to DynamoDB, in which the item will be stored. All items with the same partition key value are stored together in sorted order by sort key value. So this is so when you have two like partition key and sort key, all the partition key which has same value are stored together, but it be sorted at lower level. So just think of a table and you just group by or something like that, sort by. So basically it be stored or saved in that order based on the sort key. In a table that has a partition key and a sort key, it is possible for multiple items to have the same partition key value. So if you have both the keys, you can have same partition key value, but sort key will be different. However, those items must have different sort key values. So that's why, because both of them combined together becomes the primary key. So you must have sort key separate, but you can have same partition key in case you are using composite primary key. Okay, next is secondary indexes. So primary key, what we have seen is partition key and sort key. That is the primary way of storing the records and retrieving that records. So now let's see secondary indexes. So what I talked about was the primary indexes, because that is the obvious way of storing or retrieving items. So you query data using the alternate keys. Secondary indexes allows you to query the data in a DynamoDB table using keys other than the primary key, which provides more flexibility in accessing your data. Then first we have global secondary index, which is called as GSI. You have different partition and sort keys. A GSI is an index with a partition key and a sort key that can be different from those on the base table, enabling queries across the entire table. So it is different from the main primary or the sort key. So this is additional, you can create global secondary indexes. Then you have local secondary indexes known as LSI, which has the same partition key but different sort key. So in the global secondary index both are different, but in the local secondary index partition key is same as the primary key but different sort key. So an LSI is an index that shares the same partition key as the base table but has a different sort key, which allows for additional query options within a partition. And GSIs span the entire table. Global secondary indexes are designed to cover the entire table, enabling queries across all partition keys for efficient data retrieval. And there is some default quota, so you can have up to 20 global secondary indexes and 5 local secondary indexes per table, which provides sufficient indexing options for most use cases. So you can have one primary key, sort key on the base table, then you can have up to 20 global secondary indexes. So you can have 20 different combinations of your partition key and sort key apart from the base table, and then you have 5 local secondary indexes, which means again you can use those 5 base table partition key along with 5 different sort keys. So this will give you a lot of permutation of combinations of how you want to store or retrieve the information faster. So next feature is DynamoDB streams. DynamoDB streams is an optional feature that captures data modification events such as the addition, update or deletion of items in DynamoDB tables. The data about these events appear in the stream in near real time and in the order that the events occurred, ensuring timely and accurate data capture. When a new item is added to the table, the stream captures an image of the entire item, including all of its attributes, providing a complete snapshot of the new data. When an item is updated, the stream captures the before and after images of any attributes that were modified in the item, which allows for easy tracking of changes. When an item is deleted from the table, the stream captures an image of the entire item before it was deleted, preserving a record of the data prior to the removal. Each stream record also contains additional information such as the name of the table, the event timestamp, and other metadata, providing valuable context for the captured events. Stream records have a lifetime of 24 hours, after which they are automatically removed from the stream, ensuring that the stream remains manageable and focused on recent events. DynamoDB streams can be used together with AWS Lambda to create triggers code that runs automatically when an event of interest appears in a stream, which enables powerful event-driven architectures and real-time data processing. Next, we'll see some consistency model. So when reading data from DynamoDB, users can specify whether they want the read to be eventually consistent or strongly consistent. So first is eventually consistent reads. So this is for read only, which is the default. So the eventually consistency option maximizes your read throughput. However, an eventually consistent read might not reflect the result of a recently completed write. All copies of the data usually reach consistency within a second, and repeating a read after a short time should return an updated data. Next type is strongly consistent reads. In addition to eventual consistency, DynamoDB also gives you the flexibility and control to request a strongly consistent read if your application or an element of your application requires it. A strongly consistent read returns a result that reflects all writes that received a successful response before the read. And lastly, we have ACID transactions. So DynamoDB transactions. So this is a transaction. This is a slightly different feature. So the DynamoDB transactions provide developers the features like atomicity, consistency, isolation, and durability across one or more tables. So this is when you have table and multiple items across one table or multiple tables within a single AWS account and a region. Then you can use transactions when building applications that required coordinated inserts, deletes, or updates to multiple items as part of a single logical business operation. Okay, next is DynamoDB table classes. DynamoDB offers two table classes designed to help you optimize for cost, allowing you to choose the most suitable option for your workload. First one, standard DynamoDB standard table class, which is the default and is recommended for vast majority of workloads, which provides a balance between cost and performance. Then you have DynamoDB standard infrequent access, standard IA table class, which is optimized for tables where storage is dominant cost, such as those storing infrequently accessed data like application logs, old social media posts, e-commerce order history, and past gaming achievements. Every DynamoDB table is associated with a table class, with DynamoDB standard being the default. All secondary indexes associated with the table use the same table class. So secondary indexes in the sense local secondary indexes and global secondary indexes use the same table class. Each table class offers different pricing for data storage as well as for read and write request, which allows you to select the most cost-effective table class based on your table storage and throughput usage patterns. The choice of a table class is not permanent. You can change this setting as your requirements evolve, providing flexibility in optimizing cost over time. You can manage your table classes using Management Console, CLI, or SDK. DynamoDB also supports managing your table class using AWS CloudFormation for single region tables and global tables. Okay, next topic is Amazon DynamoDB read and write capacity modes. So first we have on-demand mode. DynamoDB on demand is a flexible billing option that adjusts to the level of traffic without capacity planning. This mode has pay per request pricing and tables. Using it offer the same latency and security features as DynamoDB. Next one is a provision mode, and this is the default mode. So on demand is non-default, and this is the provision. This is the default mode. This is also eligible for free tier usage. You can specify the number of reads and writes per second, and you can adjust the table's provision capacity based on traffic changes. This provides cost predictability by allowing users to forecast capacity requirements. So read and write mode significance. So basically the mode will determine the charging method, how you are charged for read and write throughput, and how to manage the capacity. You can either set it while creating a table or change it later. Secondary index relation. So secondary indexes will inherit the read-write capacity mode from the primary table. So basically local secondary indexes and global secondary indexes will have the same capacity modes what you set for the base table or the primary table. So just talk a little bit on on-demand mode. So on-demand mode can handle a high volume of requests seamlessly. The mode automatically adjusts the capacity based on demand, and this comes for pay only for what you use, and this flexible billing option ensures users pay for their actual usage. Despite fluctuating workloads, DynamoDB promises low latency, and this is compatible with existing DynamoDB APIs, so users can switch to on-demand mode without changing any code in their applications. So actually this provision mode was the older mode, and on-demand is the newer mode. So that's why they say there is no application code change required if you wish to go from provision to the on-demand. Basically you are going from an older mode to a newer mode. Okay, next one is provision mode. So specify the expected read and write throughput based on your application needs. So you basically manually set it. Provision mode allows for automatic adjustment in capacity in response to traffic variations. So there is an option for auto scaling adjustment. Cost predictability. So by forecasting capacity needs, users can better predict their cost. Provision mode is beneficial for applications with consistent traffic patterns. If your application sees a gradual increase in traffic, provision mode can be a good fit. And by anticipating capacity requirements, users can better manage their cost. Okay, now let's see some DynamoDB APIs overview. So first is control plane operations. This handles creation and management of DynamoDB tables, indexes, streams, and dependent objects. PartyQL, which is a SQL compatible query language to interact with DynamoDB for executing statements and batch operations. Procedures such as put item and batch write item, which handles the addition of items to tables. Techniques or APIs like get item, batch get item, query and scan to retrieve items from the tables. APIs like update item for modifying item attributes in the table. Procedures like delete item and batch write item to remove items from the table. And then next we have DynamoDB stream operations. So these include methods to manage and access data modification records in streams such as list streams and describe stream. And then you have transactions, which provide asset properties to maintain data correctness. Users can use either PartyQL or classic CRUD APIs for the transactional operations. Okay, next feature is global tables. So DynamoDB global tables support multi-active and multi-region replication, catering to distributed applications. So this is active and between multiple regions. So let's say you can have one in US, one in Europe, and both will be serving traffic at the same time. Replication. So changes made to any item in a replica table are replicated across all other replicas, typically within a second. All replicas within a global table maintain eventual consistency. So we have strong consistency and eventual. So these maintain strong eventual consistency. So next feature is DynamoDB DAX, which is called as DynamoDB Accelerator DAX. So Amazon DynamoDB offers a single digit millisecond response times in most cases, catering to scalability and high performance needs. So this is the DynamoDB product itself, which is quite fast already, but for use cases require even faster response times, which is less than single digit millisecond response time. DynamoDB Accelerator DAX delivers microsecond latency. So by default it's millisecond without DAX, but DAX will make it microsecond latency when accessing eventually consistent data. DAX is a caching service that is fully compatible with DynamoDB, enabling applications to benefit from fast in-memory performance. By serving as an in-memory cache, DAX reduces the response times of eventually consistent read workloads from single-digit milliseconds to microseconds. And DAX is a managed service that is API compatible with DynamoDB, requiring minimal functional changes to integrate with existing applications and reducing operational complexity. For read-heavy or busty workloads, DAX provides higher throughput and potential cost savings by reducing the need to over-provision read capacity units. And applications that frequently read the same individual keys can significantly benefit from using DAX, as it optimizes performance for repeated reads. So basically you have a DynamoDB service and you create a table, which is the main unit. All you do is create this DynamoDB DAX cluster, and initially without DAX your code will talk to DynamoDB, but once you introduce that, it will act as an in-memory cache. So it will just cache repeated reads and all over here. So this will in general will improve the performance greatly, and this will go from if it's millisecond, by introducing DAX it will be like microsecond. So a couple of options. So let's say how create table looks like. So in this example, we are creating a DynamoDB table which has table name music. Artist and song title has data type string. So artist and song title. So this is type string. Artist is the partition key denoted by key type hash. So over here, key type. So key type. We are saying key schema. So attribute definitions will have data type and key schema. So this is the partition key. So in the code we call it hash, and this is the sort key. So sort, just remember range. So song title is the range and artist is the partition key. So some common operations. So let's say writing item to a table. So in the music table, I'm just writing some item, but I'm just picking it from a JSON file. Then read item from a table. So put item, get item, table name. I'm storing it to a JSON file. Delete item. Just so the key is in the JSON file. And how to query a table? You just do a DynamoDB query and key condition expression, artist name, artist, and song name, song title. And to delete a table, delete table, and to list table names, DynamoDB list table. So basically you use AWS APIs. This example is based on AWS CLI command. So AWS space DynamoDB, and after that you can put your operation. So all CLI follows the same pattern. You have AWS service name and what operation you want to perform. And that's all. Thanks for watching.